Assalamu alaikum, my dear students. How are you? Hope all of you are well by the grace of Almighty Allah. Welcome to EBS Home School. This is Shahjadi Akter, Assistant Teacher of Science of National Ideal English Version School Day Shift. Today I am going to take a physics class for class 9 students. My dear students, our today's topic chapter 7, reading turn part 1. Our today's lecture number 24 and SW number 21. Let's start our class. This is chapter 4, wave and sound. At first, today we will discuss this chapter, and at first we will discuss wave. What is wave? My dear students, here given the definition of wave. Okay, here given the definition of wave. Wave is a process of transferring energy from one place to another through a medium, where the particles of the medium can oscillate about their position but are not displaced permanently from there. My dear students, you have to memorize this definition. What is wave? Wave is a process of transferring energy from one place to another through a medium where the particles of the medium can oscillate about their position but are not displaced permanently from there. So, wave is one kind of energy. Wave is a process of transferring energy from one place to another through a medium where the particles of the medium can oscillate about their position but are not displaced permanently from there. Here see, all of us have seen waves when a stone is thrown into water, then waves spread out in all directions from the point. When a bulb is switched in a room, the light that spreads in the room is also a wave. When we talk, the sound that reaches from the place to another place is also a wave. When a compressed spring is released, the deformation that propagates through it is kind of a wave too. So, here given the examples of the wave. Now come to the characteristics of wave. Okay, now we will discuss about the characteristics of wave. While discussing wave, several types of characteristics arise. Here we will discuss all the characteristics of wave, especially the mechanical waves. Number 1, for mechanical waves, a medium is necessary. Okay, for mechanical waves, medium is necessary, and wave can be created in water, a wave can be transmitted in a spring, a wave can be created in a rope. The sound we hear is also a wave, and it is a medium is air. Its medium is air. So, for mechanical waves, this is the characteristics of waves. For mechanical waves, medium is necessary. Number 2 characteristics, when a wave propagates through a medium, the particles of the medium oscillate about its own position but are not displaced permanently with the wave. Okay, this is the second characteristics of wave. Now come to third characteristics, energy can be transferred from one place to another through wave. This is the third characteristics of wave. Energy can be transferred from one place to another through waves. The more the energy, the more the amplitude of the wave. Energy is proportional to the amplitude of the wave. Now come to fourth characteristics. Every wave has a velocity. Okay, this is another characteristics of wave. Every wave has a velocity. Now come to characteristics number 5. Reflection or refraction occurs for wave. Okay, reflection or refraction occurs for wave. This is another characteristics of wave, and the last characteristics is, among all the characteristics of waves, the most important is superposition. Okay, that means superposition is the another characteristics of wave. Now my dear students, I am repeating this. The characteristics of wave. Number 1, for mechanical waves, medium is necessary. Number 2, when a wave propagates through a medium, the particles of medium oscillates about its own position but are not displaced permanently with the wave. Third characteristics of wave is, energy can be transferred from one place to another through wave. Number 4 characteristics, every wave has a velocity. Number 5, reflection or refraction occurs for wave. And number 6 is, among all the characteristics of waves, the most important is superposition. And here see this figure, this is the figure of wave. Okay, now come to types of wave. How many kinds of wave? See this, when a wave propagates through a spring, the here given the picture of the longitudinal waves. Longitudinal wave. There are, my dear students, we have we'll discuss these types of wave now. This is the waves are of two kinds here given: longitudinal wave and the transverse wave. What is longitudinal wave? The wave that travels in a direction parallel to the direction of vibrating. What is longitudinal wave? The wave that travels in a direction parallel to the direction of vibration of the particles of the medium is known as a longitudinal wave. And for example, sound wave. Okay, so sound wave is the example of longitudinal wave. Now come to transverse wave. The wave which moves perpendicularly to the direction of the vibration of the particles is called transverse wave. And for example, water wave. My dear students, now see this example. See this figure. This is the sound is a longitudinal wave of compression of refraction, compression and refraction created by the pressure in air. Here lambda is the wavelength. Okay, this is the sound wave. This is the figure of sound wave. So, we have learned what is longitudinal wave, and what is transverse wave. Okay, now come to this page. Simple harmonic motion. What is simple harmonic motion? The harmonic motion of constant amplitude in which the acceleration is proportional and oppositely directed to the displacement of the body from a position of equilibrium is called the simple harmonic motion. And you have to memorize this definition. Now come to the next question answer. This is important question answer. Establish a relation between frequency and time period. Okay, establish the relation between frequency and time period. That means we have to prove that F equals to 1 divided by T. Here F means frequency and T means period, time period. Okay, this is the answer. The time required by a vibrating body to complete a cycle is called period, and the number of cycles completed by a vibrating body per second is called the frequency. My dear students, all of you have to memorize this definition properly. What is period? The time required by a vibrating body to complete a cycle is called a period, and the number of cycles completed by a vibrating body per second is called the frequency. So, if the period of a vibrating body is T, capital T, if the period of the vibrating body is capital T, then the number of vibration in T second equals to 1. Number of vibration in T seconds equal to 1. So, number of vibration in 1 second will be 1 divided by T. So, the number of vibration in 1 second is the frequency. We know what is frequency. The number of vibration in 1 second is frequency. That means this is frequency. So, F equals to, if the frequency is F, then we can write F equals to 1 divided by T. Okay, this is the relation between time period and frequency. Okay, F equals to 1 divided by T, and this formula you will use to solve mathematical problem also. My dear students, I am repeating this formula again. Establish a relation between frequency and time period. The time required by a vibrating body to complete a cycle is called period, and the number of cycles completed by a vibrating body per second is called the frequency. If the period of the vibrating body is T, then the number of vibration in T second equals to 1. So, number of vibration in 1 second is 1 divided by T, and the number of vibration in 1 second is called frequency. So, it will be F equals to 1 divided by T. That means the frequency equals to 1 divided by T. So, this is the exact relation. Now, come to this question. Prove that V equals to F lambda. Prove that V equals to F lambda, my dear student. This is another important question, relation. Okay, we know, answer will be, we know the number of time periods present in 1 second is the frequency. Again, you have to write this definition. What is frequency? The number of time periods present in 1 second is the frequency. And again, the distance traveled by a wave in the time period is the wavelength. Okay. My dear students, see this, V equals to F lambda. Here V is indicated by wave velocity, F is frequency and lambda is wavelength. Okay, lambda is called wavelength. We will indicate it by lambda by wavelength. F is frequency and V is velocity. Okay. So we know the number of time period present in 1 second is the frequency. Again, the distance traveled by a wave in one time period is the wavelength. If the wavelength is denoted by lambda, the distance traveled in the time of one complete vibration equals to lambda. So the distance traveled in the time of F complete vibration equals to, it will be F lambda. So here frequency is F, here frequency is F. So F number of waves are produced in 1 second, and we know distance traveled by the wave in 1 second is called wave velocity. So we will write distance traveled by the wave in 1 second equals to F lambda. That means here this is wave velocity V. So V is a wave velocity. So therefore velocity of wave V equals to F lambda. My dear students, I hope you have understood this question, and this is very important for your exam. And now I will give you HW. Your today's HW number is 21, and your HW topic V equals to F lambda. Prove that V equals to F lambda. That means this question answer do as your HW. My dear students, I hope all of you have understood our today's topic. Memorize properly all the definitions and question answer. Keep practicing at home. See you again in the next class. Allah Hafiz.